Rari.
जी सर.
Next part is the response to the general dynamic loading. We have discussed first about the free vibration, undamped free vibration, damped free vibrations, harmonic loading, time history analysis. And now the load, which is a general dynamic load, it is not a periodic load, but a specific different types of loadings are there because we are heading towards the earthquake loading. So basically, this topic is linked with the general dynamic loading. The reason is that the structure or any other basically system can be subjected to sometime to different loads like blast loading, step loading, and this is in these slides brief proof is also there, but mainly the response of the different system is shown. I mean, in the book also these are available, and some of the examples problems related to the general dynamic loading. So I will just show you the mainly the response that is obtained for the different kinds of the loadings, and basically how do you compute these response. That is also the part of the lecture. It's bit complex. The reason is that the load is not simple. That is the reason. For linear system, the response to the general dynamic loading basically is obtained by the dividing the force into a series of impulses, and total response is obtained by superposing the response to individual impulse. You know that this earthquake load will also be a complex load, and all other loads are very complex. Now the point is that if the load is not a periodic load and it is a general kind of loading which is changing every time, so how can we compute it? So it is not difficult. We can select a short interval ले लें and dt, and in that dt आप जो है वो सुपरपोजिशन करते जाएं, taking the short time intervals to find out the response, and then finally superimpose the superposition, apply the principle of superposition for individual response and integrate that from 0 to the total time, and then you are able to get the total response. So an integral is formed. ये जो integral है that is formed by superposition is called as convolution integrals, or by the famous Duhamel integral भी इसको हम कहते हैं. So this Duhamel integral will be used to solve the superposition problem for response to the general dynamic loading. Short duration or the non-periodic loads are known as the impulsive load or the shock load. ये जो non-periodic loads हैं, blast load, dynamic load is automobile, traveling crane, and other mobile machinery may be categorized as the shock load. इनका जो response है, the response to these load is transient. ये transient response है, and in nature and decay rapidly ये decay होता है. However, from the structural engineering point of view, the displacement and the stress is induced are more important than the durations. So rather than the duration in the structural engineering, you know that the displacement and the stresses which are developed even during the short interval of the time. This is important, that what is the response of the structure. Because of the short duration of the response, damping does not have a significant influence. Damping केस में कम रोल है because the response is very short है. ये जैसे आप कहते थे ना कि ओवर डैम्पिंग का जो response आता था, the structure response, so it's very short response, there is no vibration kind of things mostly. आप देखेंगे कि outcome कैसे आता है, और यही interesting है that you try to plot the outcome for the different response. What is the outcome of the machinery loading? What is the outcome of the blast loading? And what is the outcome of the other loadings? This is important that you should know that what is the outcome of the different loadings. So for example, starting with the impulsive force, what is the response of the impulsive force? A large force acting for a very short duration of the time is known as impulsive force. A very large force but for very short duration. So this will give you some idea that how you can see the response of the system, how you can plot the response of the system. This is also you can see that. So the magnitude of the force may be infinitely large, but its time integral जो है, time जो है that is very finite. Let's say at t, the from t to t plus epsilon increment, there is a force, and you can compute the impulse, the force into the time. So epsilon is very small interval of the time. So mathematically, an impulsive force can be expressed in terms of the delta function. The function is centered at t is equal to 0, and at infinitely large value at t0 and 0 at all other locations. So alternatively, this impulse is shown in form of rectangle in the bottom. So impulsive force can be shown. This is an impulse which can be shown in this form also, that it's very small, a very high value of the force for a very small interval of the time. So the impulsive force analogously, the impulsive force centered at t is equal to tau. Basically, impulsive force which is centered at t is equal to tau of the impulse I delta is t minus tau. So during the interval 0 to t is equal to tau, we are saying it as tau. I mean the final time जो है ना, इसको हम tau कह रहे हैं. So during that time, the total impulsive force will be the total value of the load into that small time interval. That is called as the I delta. So the impulse will change the velocity of the system with mass m. Velocity will also change. And the response to impulse is the initial velocity problem for an undamped system जो है. So the response of this system जो है, that will be the initial velocity problem. We can compute it. The response to I is equal to 1 is called the unit impulse response, and it is denoted by ht. ये unit response plot है. और damped system के लिए हम ये यानी कि u को आपने replace करते जाना है. The function that we study for the damped system is the e minus zeta omega t sin omega dt. So this is for the damped system. अनडैम्प्ड के लिए जो है वो ये ए साइन ओमेगा टी, तो ये इसका कांस्टेंट इनिशियल वैल्यू प्रॉब्लम था ना, ए साइन ओमेगा टी प्लस बी काज ऑफ ओमेगा टी. सो दिस यू इज ऑब्टेन्ड फ्रॉम दैट, एंड दैट इनिशियल कंडीशन से हम कहते हैं कि वेलोसिटी इज आई ओवर एम. वेलोसिटी की वैल्यू पुट कर दी वी नॉट ओवर ओमेगा इंटू साइन ओमेगा टी, तो वहाँ से ये यू आया. यू कैन सी द अनडैम्प्ड फ्री वाइब्रेशन फार्मूला for the velocity. तो ये velocity problem बन गई. So this is the impulse response for the system. Then in the response of the linear system to general dynamic loading के proof के लिए basically it can be obtained by dividing the total response into many small steps. You can divide the response into the small steps and superposing the response to individual impulse, और individual को फिर super sum करते जाएं. For example, the response for this at any instant du is given by p tau, that how much load is acting, and what is the d tau, what is the interval, divided by m omega sin omega t minus tau. So just putting that time difference and then integrating it from the 0 to t. आप 0 to t integrate करें तो overall you can get the response of the general response. Damped system, this is for the undamped system, and this is for the damped system. You can find the response for the damped. This is a general formula for getting the response. You can write in the damped and undamped, दोनों के लिए अगर आपने लिखना हो generally, so this is the response: load into ht minus tau into d tau. The above integral is known as convolution integral or Duhamel integral. This integral is known as the convolution integral. What are the values? It provides a general method of analysis of the linear system subjected to any arbitrary loading for the development of the Fourier transform method. You can apply the Fourier transform method also to solve this integration problem for simple function. P tau closed from the solution can easily be obtained. In other cases, numerical technique must be used. अगर function simple है and closing is closed form solution can be possible. Otherwise, other technique can also be used. For a system with non-zero initial condition, when the initial conditions are not zero and the system is already under some initial condition, we have to add the response before that. Initial conditions क्या हैं? You have to add the response of the damped system initial conditions, and then you can add the convolution integral, Duhamel integral, to find out the total response. For example, if one system is applied with the constant load, constant force P naught apply होती है किसी structure पर, so what will be the response of the system? This is a P naught, no, इसमें periodic नहीं है, straight load लग रहा है, so P naught, this is the equation of the motion. So इसको हम particular solution करेंगे. I mean we will take the derivative also and make it zero, and then we take the value of the constants. So the constant which is obtained in this case is P naught over K, and U is equal to complementary solution is this one, and the total solution for this problem is only P naught over K, because this is a sin omega t and the periodic function is not present. So ये total इसका आता है solution इस case का. और zero initial condition के साथ these are the A and the B value, and this is the putting all the values. Basically, I am interested in the final response. The final response of the system, although it is a P naught, a constant load is applied, but it is a system which is already under the effect of the vibration. So if the P naught is acting on that, what is the response of the system? So it actually depends upon the conditions and the damping also, whether the damping is present or not. So you can see that, and this is the response for the different value of the damping. अगर damping जो है आपकी कम होगी तो you can see the response. So this is the displacement ratio U over P naught over K. इसको इधर ले आए, and this response is basically giving you the outcome. For the damping problem, you have already studied this curve. And when you are step function अगर होगा, so then what will be the response to the step function? That is the response, peak response to the step function. So the time at which the peak response occurs is obtained by differentiating the above equation and equating to zero. इस equation को आप जो है differentiate करें and then make it equal to zero. That will give you the peak response for the different value of the time interval, and this is the peak response of the system. So initially it will go to the peak response, and as the damping is increasing, the peak response value is, because it is depending upon the damping, so peak response is decreasing. So you can also apply the Duhamel integral to find out the peak response. ये रैम्प फंक्शन है, फिर ये अब मैं सारे I will tell you the different functions, what are the different functions and what are the values of the response. I will show you. This is the force function, this is the response. So there are many active functions, so you must know that what is the force. If the force is applied linearly increasing, the function of the force is linearly increasing and ending at T1. How you can represent that force? इसको आप कैसे लिखेंगे? So PT will be You first need to write that what is the function of the force. Force का function क्या है ये आपको पहले लिखना है. So Pt is P naught into T divided by T1 Tt. ये आपका फंक्शन है इस फोर्स का. Pt over P naught into T divided by Tt. So who put the value of that? The Duhamel integral for the ramp function जो है Duhamel integral क्या होगा? Function of the force. T क्या है यहाँ पे tau for that and T1 is the maximum value and then you multiply that with the function that is e zeta omega t and sin omega dt. इससे multiply करते हैं. This is the Duhamel integral and then you can solve the response of the system. This is the response of the system which is obtained for the ramp function. इसको हम ramp function कहते हैं. When you plot that response, displacement जब हम plot करते हैं as a function of the, ये displacement ratio है basically because you divide the response with the static displacement पे आप इसको divide करते हैं. Displacement obtained by the force divided by the static displacement obtained at this P naught. तो ये आता है. आप वैसे P naught over K को राइट साइड पे भी इसको होल फंक्शन को भी प्लॉट कर सकते हैं. तो सो यू हैव दिस काइंड ऑफ रेस्पॉन्स. दिस इज obtained. जब आपका T1 over T2 होगा देन व्हाट इज द रेस्पॉन्स? इट इज जैसे जैसे बढ़ता जा रहा है ना कर्व होगा. ये पहला जो है ये T over T1 1 पे था. दिस इज फॉर 1 and this is for the 2. Then is the step function with rise time and then if you have the step function, ये तीन तरह के different है ना function. So negative ramp function आ गया, positive function आ गया and then the ये है कि your function is one is like that for u1 and one function is going like that. ये हमने you have already discussed this first case. First case का response जो है that is already discussed. So then the after that if it is become constant, जब constant हो जाएगा, so ramp function applied at t0 given by u1t and equally negative ramp function जो है अगर negative आ जाता है function, पहला तो यहाँ से ले लिया ना the first part. This one is the same which is obtained in the previous case. And the second one response which is the negative ramp function. This is the response of the negative ramp function. The total response will be the summing the response first and the second response. This is the first response. This is the second response. So for t less than t1, this is the response. For t larger than t1, this is the response. Negative function का अलग response होगा. And when you plot the response, जब आप plot करेंगे u divided by this or t over t1, you get this type of curve. Please try plotting these functions in the MATLAB. Taking कौन सा वेरिएबल होगा, ओमेगा आपका सिस्टम का होता है, दैट इज T1 आप लोग खुद डिसाइड भी कर सकते हैं. T1 इज वेरिएबल, T इज वेरिएबल, ये मैट्रिक्स होगा T1 एक सिंगल वैल्यू होगी एंड बाकी P नॉट फोर्स है, K जो है वो स्टिफनेस है. तो किसी भी फ्रेम के लिए व्हाट यू आर सॉल्विंग प्रीवियसली, ट्राई टू सॉल्व दिस प्रॉब्लम, द फ्रेम दैट यू आर सॉल्विंग ऑलरेडी. Response spectrum है ये आगे separate topic है, so not giving the detail. Response spectrum is a curve drawn from any response quantity of single degree of freedom system against natural period of frequency. So response is basically giving us the peak response of the structure. So we can get the peak response from the different time history. Time history से peak response जो आप plot करते हैं उसको हम response spectrum कहते हैं. Now there is a example that load है that is decay exponentially decay कर रहा है. So what does that mean? कि there was a load. Now I say decay कर रहा है तो it means कि e raised to power minus alpha t. अगर वो increase कर रहा होता तो plus alpha t, but minus at or minus alpha t, so it is decaying. this is telling you that the load which is exponentially decay हो रहा तो उसको आप ऐसे represent करते हैं. PT आ गया, you can just put the values. Damping को आपने ignore कर दिया, so this is the equation of the motion for this system, and then the solution to the equation, initial condition, and then obtaining the Duhamel integral, putting the value in the Duhamel integral and ut, and further simplifying that. Because in this case the A is also present and EAT, so the function when you solve this problem you get the integration problem. इसको solve किया so you get this answer, and the function EAT is added in that. Total response इसका बनेगा when the load is suddenly decaying, I mean certain value थी exponential decay कर रहा है, तो when you plot this it is like this behavior is, आप देख रहे हैं कि positive था, then the negative accelerated displacement is increasing, and at one time it will suddenly finish. It depends upon time. So try plotting this function. ये last वाला है इसका, विदाउट इंटीग्रेशन है सारों का ना, ये गिवन है, इंटीग्रेशन सॉल्व किया गया. ये ब्लास्ट का केस है, व्हेन द ब्लास्ट लोडिंग इज अप्लाइड ऑन द स्ट्रक्चर, सो दिस इज अ प्रॉब्लम आल्सो व्हिच इज गिविंग, एंड दिस इज द ब्लास्ट लोडिंग. ब्लास्ट लोडिंग भी जो है ना, दैट डिके लाइक, इसका फंक्शन थोड़ा डिफरेंट है. इट वाज गिवन इन द प्रॉब्लम में गिवन था फंक्शन 100 टाइम e रेज टू पावर माइनस AT माइनस e रेज टू पावर माइनस BT, यानी कि डबल फंक्शन था. पहले ये था इसका फंक्शन, फिर आपका इसका ये फंक्शन है. ओवरऑल जब इसको एक फंक्शन बताना हो तो ये होगा, फिर ये कम्प्लेक्स हो जाता है ना व्हेन यू हैव द टू फंक्शंस, यानी कि एक फंक्शन इंक्रीजिंग में था फिर डिक्रीजिंग ऐसा, तो ये थोड़ा इसका फंक्शन एडवांस हो जाता है. डेफिनेटली you have to see the curve function for that, but it is interesting because the response normally इसी तरह का होता है blast loading का, कि suddenly it increases and then suddenly start decreasing. तो इसको आप लिख सकते हैं 100 e raised to power minus AT minus e raised to power minus BT. P जो है ये प्रेशर है, सडन जो प्रेशर पड़ता है इसका ब्लास्ट का स्ट्राइकिंग ऑन द बिल्डिंग, एंड द बिल्डिंग फेस सब्जेक्ट टू द विंड प्रेशर. जो बिल्डिंग का जो प्रेशर का एरिया है वो 144 है, एंड द मास ऑफ द बिल्डिंग एज्यूम कंसंट्रेटेड एट फ्लोर लेवल. टोटल स्टिफनेस ऑफ द कॉलम सपोर्टेड कॉलम की गिवन है. फाइंड द डिस्प्लेसमेंट रेस्पॉन्स ऑफ द बिल्डिंग एंड द मैक्सिमम बेस शियर induced by this pressure wave due to the blast. So omega is computed first of all. फिर फ्लोर लेवल पे जो लोड आप अप्लाई हुआ आपका वो कितना होगा, ये ब्लास्ट इंड्यूस प्रेशर वेव की वजह से है. तो फ्लोर लेवल पर कितना एरिया होगा, क्योंकि हमने आधा एरिया लेना है, ठीक है ना, क्योंकि ये है ना आपका नीचे, बाकी हाफ ऑफ द पार्ट इज गोइंग इनटू द बेस एंड हाफ लोड इज शिफ्ट इन देयर. सो 144 डिवाइडेड बाय 2 कर देंगे, डिवाइड मल्टीप्लाई बाय द प्रेशर. प्रेशर का फार्मूला दे दिया, एरिया हाफ ले लिया, टोटल दिस इज द टोटल फंक्शन. अब फंक्शन आ गया आपके पास. आफ्टर गेटिंग द फंक्शन नाउ यू कैन मेक द, you have studied in the previous slide कि क्या response आता है. If you have the function now you have the p value, it means कि p आ गया. The applied force has two exponential decay component, therefore the total response is obtained by summing the component as per principle of superposition. तो ये पहला component है. The second component, just following that. So this is the due to the blast induced pressure. Putting the value of this all, you can solve the response of the system in terms of E आएगा T, and you can vary the time. Now time vary कर लें, put करें 1 to different interval T over T, and you can plot this response of the स्ट्रक्चर टॉप डिस्प्लेसमेंट है ये U इस पे इसका रिस्पांस ऑफ द स्ट्रक्चर ड्यू टू दिस लोडिंग wind pressure blast loading response to the shock impulse loading the response as shock when you have the uh, some loading which is applied here and then negative loading. So this case was already dealt, but then suddenly it is dropping. So when the load is less than T1, this was already proved. When the load is less than, for larger than T1, now the point is that when the load is larger than T1, the response is obtained from superposition of above times function at T0 and equal but negative step function applied at T is equal to T1. So first function this one and negative for T1 जो है इसके लिए आप negative function apply करेंगे. Just for T1 के लिए जो है वो this is at T1 and for T larger than T1 जब आएगा तो then this second one T cos omega T minus T1. So this response is at the T equal to T1 आ गया ये total response T larger than T1. So summing all the response you will get the total response in that case. ये rectangular pulse है. In that case you have the different responses. The rectangular pulse force also called as the shock spectrum, response spectrum. Response spectra है, directly some curve is given. And for the rectangular pulse that you have seen here, the response of this pulse is shown in this graph. This is shown here that how you will get the outcome of the response and what will be the peak response. In this case, the peak response is given by the taking the derivative and then putting it equal to 0. Then you can compute the peak response also for this system. These are for the different values of the ratio of the damp time period and the natural time period. And these values are changing. Then you can see that what is the behavior. So as the ratio of this is changing, so accordingly the response of the system is also changing. This is the response of the triangular pulse. Triangular pulse can be represented as the superposition of the three ramp function, the first function, the second function, this function. So three ramp functions can be used. The first function when t is less than t1 by 2. Second when t is t to t1 and when t is larger than t1. Because initially it is starting with the 0 when t was less than t1 by 2. And again the function is same but it is starting with t1. So therefore the first response when the t1 by 2 is this one. The second response when t1 by 2 to t1. The response of the system will be this one, and the third response when t is larger than t1. So we will add this response also, and the third one is this response. This is the new response which will be added in the previous two responses. So this is in the case of the triangular pulse, and what will be the outcome of this one when we plot the behavior of this triangular pulse, the displacement as a function of the t1 over t. So this pulse, this is the behavior. So interestingly, you see that the loading and the response is not similar. Similar graphs are not obtained. Loading and the response of the system is different. And you can determine again the peak response by derivating. But this is for learning purpose that for different kinds of the loading. Similarly, the sinusoidal that we studied today, the sine pulse is there. The response in the less than T1 is this one, and the response for the larger than T1 is this is the sinusoidal response, and this is the response. If the peak response occurs in the first era, then the time for the peak. This is the peak time for the peak response. So this, you can also compute that what will be the time for the peak response, and when you plot the response for the sinusoidal wave, then this kind of response can be obtained for the structure. Structural जो response बनता है for displacement, I was showing you some response spectra today also, that what is the response that is obtained for the structure. So the peak response to है, that is basically representing the response spectra, and you can determine the peak response in case of the sinusoidal wave by using this approach. This is another function where one velocity pulse was applied to the structure. एक velocity आप लगाते हैं structure को, and then suddenly it becomes zero at the end. ये कौन सा function होगा? Triangular function but decrement function जो है triangular में जो second part है. So when the t is equal to less than t1, तो फिर इसका क्या response होगा structure का? So you can put down the same value in the formula. It is given as our velocity. So what is velocity? V naught. You can represent this velocity as this function V naught initially, and then 1 minus t over t1. ये velocity का function है. What will be the acceleration? Acceleration is basically the minus V naught over t1. So generally the equation, governing equation of the motion is this one. So the response of this system, it is subjected to the velocity. यानी कि पहले आपने जो पढ़ रहे हैं वो सारे force के हैं. So not necessarily कि आप force की बात करें, because the ground acceleration की भी हम बात कर सकते हैं कि structure is subjected to the ground acceleration or the ground motion. Structure को जब ground motion subject होता है, so then what happens to the structure? So this is the response of the structure when it is subjected to the velocity. So velocity is there. It means that velocity अगर है तो आपके पास acceleration भी आ जाएगा. Now you can determine the response of the system also. So how you can determine? You have the initial condition. Let's say the ground displacement was 0. Now the velocity is applied. So total velocity is the velocity of the system minus the ground velocity, the initial velocity of the system. So the response of the system in this case is this one, and for t less than t1, and then putting the value, it can be written like that. Sin omega t, cos omega t, cos omega t. So in this case, when the structure is subjected to the velocity, so then the displacement is obtained, and this is the t1 over t. So when the structure is subjected to the some velocity, or any system is subjected to the velocity, then for the less than t1, this will be the response, and after that this will be the response, where you need to know the initial velocity value, and that's all. Omega is for the system, t1 आपको पता हो और v naught पता हो, so you can compute the response of the system for the velocity, and this is the response to the ground motion. This is the response of the system when the velocity, certain velocity is applied to the structure. ग्राउंड मोशन से इसको सिमुलेट कर दिया गया ना कि वेलोसिटी अगर आप अप्लाई कर रहे हैं तो ग्राउंड मोशन से सिमुलेट कर. सो इन द टुडे लेक्चर व्हाट वी डिस्कस्ड अबाउट द वेलोसिटी रिस्पांस व्हेन द वेलोसिटी इज अप्लाइंग. वी डिस्कस्ड अबाउट द साइनोसाइडल ट्रायंगुलर रिस्पांस क्या होता है सिस्टम का. ट्रायंगल्स हैं तो क्या आंसर है. ये सब फार्मूलाज हैं 20 पेज. देन रेक्टेंगुलर पल्स है तो यू हैव सीन दिस एक्सप्रेशन कि व्हेन द रेक्टेंगुलर पल्स इज एक्टिंग ऑन द स्ट्रक्चर, blast or pressure loading is acting on the structure, then what is the function? And suddenly applied load that decays exponentially, it is a kind of the blast loading. And what is the response spectrum, that we will discuss later. And then the response to the step function, then response to the line function, response to the linear function, and response to the constant load function. So this was a general topic because you must generally know that, and you should be able to plot some responses of the structural system using the response formulas which are available, and you should be able to find out the response of the system for any kind of the loading.
एक्सक्यूज मी सर, नमाज का टाइम हो गया, अगर ब्रेक दे दें आप।
जी जी बस ख़त्म कर रहे हैं। ये ना थोड़ा रिस्पांस की एग्जांपल्स हैं 4.4 ये impulsive expansion है and then it is plotted in the MATLAB. So try to solve the examples from the book regarding the response of the system. ये एक टैंक है example 4.3. Try to solve the example that when the linear function is applied, then constant, then again you have to solve it, and then please draw the response of this tank in the MATLAB also. Similarly, and one another problem जिसमें spring system है which is subjected to this force and response is plotted. So try solving some examples, okay, and then you will be able to learn about how the response of the structure can be plotted for the different case of the loading. Okay.
ओके सर।
सर ये बुक बता दे, ये मारियो पास से करना है एग्जांपल्स।
ये दोनों ही आपकी हैं बेटा। मेन तो आप इन दोनों को ही कंसल्ट करें, मारियो पाज एंड ए के चोपड़ा, दोनों बुक्स। ओके।